name's Tate Baumricker. I'm a principal at a company called VAE. We make a software product called IT Pi, and I'm the product owner of that software package. And so today we'll talk a little bit about intent-based networking, how it can help us, what challenges we have, and where we see things going from here. This is where we're coming from. I think all of us have been in the industry long enough to know that this is hopefully in the past, or we're getting out of this position. But network configuration costs and reconfiguration costs and errors in the configuration process, where there's a lot of manual process overhead to try to control error and configuration issues, where human interaction is occurring at a high level in terms of oversight and the slowness of change as a result of that. And then even with all that oversight, we still have situations where we're having configuration problems because we're doing it in old-fashioned ways, starting to get into automation, starting to automate, but even that is sparse and in some environments not even present at all. So what we found out over time is this FAFO, or F around and find out, approach to networking just doesn't sustain. It's not something that we can do. It's not something that leads to nimbleness and accuracy and wastes time and energy, manpower, and ultimately can help us fail in missions of change in a time where we need to be fast and accurate, and things have become incredibly complicated in the environments in which we work. What do we need? We need certainty and speed. In commercial environments, that means money, right? Everybody equates that to money. For us working in the DoD or in the intelligence community or for the government, that means mission success. And so we need to pivot out of a FAFO environment into a much more dependable intent-based networking solution where, yes, we have automation today, but we add on top of that an intent-based approach to increase our certainty and speed. And as a company, VAE is here to provide those sorts of supports. We've been around quietly helping the DoD be successful for over 20 years. We've had software product that we've grown as initially as an engineering, an application that was built by engineers for engineers, and have continually improved that application to be operating at scale now globally in a accredited way to help the military understand the proprioceptive movements of their IT assets. Along the way, we've included intelligent automation in the form of intent-based networking and AI empowerment, which is now not only part of our product, but part of our development process itself. So fully embracing the expedited delivery of software and the functionality as a result. The product platform is really two things. It's the ops product, which is out there to tell you what the truth is on the ground. What is actual state of the infrastructure? And then coupled with Axiom, which is the intent-based template approach, does a lot of planning activities in terms of IPAM and content organization, which we'll see through the slideshow. The two combined deliver a really incredibly powerful functionality for IT operations, whether you're migrating to new infrastructures or whether you're sustaining in an existing operational environment and need to do dynamic changes along the way in that environment. We're here to support you. Under it all is AI augmentation, which gives us volatile facts integration to existing models, whether that's on-prem or off-prem. We can support that. So lots of incredibly capable functionality that has been built, again, from an engineering and operational standpoint into a sustaining global scale capability. Along the way, we've learned a lot of things, and as we're seeing the speed of technology advance, we're seeing the complexity of networks and infrastructures and the integrated nature of what we do become greater. We realize that we've got to have an intent-based focus that is automated to do what we've done in the past is ad hoc manual operations. And I think a lot of times people think about intent-based network and they think, wow, that's a huge leap forward and it requires that I redesign my entire infrastructure to support that. And yes, that's one way to do it. If you've got a greenfield environment, you can design it and deploy it with automation in mind. But there's a ton of ways to get into position, to learn the tools, to practice good intent-based networking with small gains for your operational community without doing that. Yes, it's helpful to have a green field because it's designed for automation, but you don't have to start there. You can start now deploying products that can do intent-based networking to support configuration drift control and compliance checking. And so that's some of the failure modes we've seen without these kinds of applications. Configuration drift is a real thing, especially in big networks and big infrastructures. Changes get made, and then folks are doing a temporary change, maybe to support a thing, trying to get the job done, and then move on with their work and forget that that configuration was temporary. Or we see a lot of times redundancy time bombs where there's deployments of an A-side configuration and no congruency B-side configuration. So we need to get out of these failure modes through the adoption of intent-based networking. So what if I told you you could? Which pill would you take? How do we get about doing this? Well, you can think about it as organizing your infrastructure with a Lego and Matryoshka doll approach. And if you guys are probably familiar with those are, but those are those nested dolls, right? The Russian dolls. And the idea is using this approach, you get inheritance and nesting of policy that can be hierarchically ascribed to your IT infrastructure, and modularity as part of that. And that's kind of the Lego part, right? So you move from a legacy situation where you've got a fixed and rigid change process that's slow, a lot of intensive personnel oversight to control it, excuse me, to a nested modular approach, which allowed you to move dynamically infrastructure in ways that you never will be able to do it before, through the inheritance model and through modularity and intent-based networking. So how to do it? Step one, track your IT. I know that seems simple, and I know that seems like, hey, that's blocking and tackling, but you won't believe the number of places that still need to improve on this. If you're not doing step one, you can't do anything. That means physical tracking. That's not just like the interfaces and the gear, but it's rack elevations, floor plans, power, cabling, all of those things, logical assignments, VRFs and prefixes and IP addresses, crypto, cyber terrain. What are the assets that you're trying to monitor and control using? What are they dependent upon? What is your attack surface? And we're not talking about tracking this stuff one and done. This is a dynamic process. Infrastructures are living and breathing creatures that need to be monitored consistently as changes occur. So taking all of your assets, whatever they are, constantly tracking them, and trying to reconcile them in a single source of truth. Maybe you've got a couple sources of truth that you federate. Either way, there's got to be a repository that's not a PDF, it's not a spreadsheet. It's something that can be used by other applications easily through APIs, GraphQL, or other means to feed information to other applications that are doing things that need to understand all of this metadata. Step two is organize a model that represents your operational truth. That could be things like who does what, who controls what area of responsibility. That could be things that are like design parameters, like the East Coast uses these sorts of services and the West Coast uses these sorts. A way to model that in software by making the dolls, so to speak, that are containers for your things. Using patterns are key, right? We're patterned people. People are patterned, like trained to be patterned. I get up and I do the same thing every morning. Having an IT infrastructure that's predictable and is patterned is a very good thing in terms of automation and templating. Then you add context to your environment, and that context is based on the dolls or the containers that you've set forth. That allows you to be flexible with JSON or YAML descriptions of the types of context you need to apply to those devices. And then of everything you're validating through schema, right? You don't want to pollute or destroy your integrity of your data. If I say I need to add an IP address to a device, I'm going to check that that is an IP address. If I need to add two syslog, like maybe the rule of my policy is I have two syslog servers for every device, that's great. We can put that into a schema to ensure that that's the case for every device. So the way to, step two is to after you've tracked all of your IT assets and you're doing so in a repeatable way, step two is to organize into a model that represents the way you operate. The reason you're doing that is because you want to be able to inherit policy. And so policy works in terms of weights, basically. So the top level, or the organization, the enterprise, if you will, should have a certain amount of consistency. And that could be things like STIGs. That could be things like configuration parameters that need to be in place for your organization, whether it's big or it's global, or whether it's small. But then you can have, and this example, there's 4 other subservient organizations, but you could have a policy inheritance that's just 2 levels, or a third that's dynamic as needed. But the idea is that you can have a policy that is for everybody, and then you can use weights to say, hey, this group inherits all that, but we override for this group, so that we can make that group dynamic and have specific mission-focused parameters. So step 3, you've got your IT assets organized, you've got a model that represents your organization, you've created buckets basically for, could be locations, could be organizational constructs, areas of responsibility. Now you're binding those assets into those containers, or into those dolls. And when you do that, you're using metadata properties to assign them to those containers, and ultimately forming dynamic groups, and that's really where the power comes in. Because you've got all your assets tracked, you've got them attributed to organizational constructs, but you can dynamically associate them for various reasons, and we'll go through an example in a moment here of how that works. The idea is that you can bind these groups together in an ephemeral sense, or a temporary sense as necessary, or a permanent sense, and attribute given context to that specific group of assets. And again, we'll go through an example to make this concrete. You always have to support sort of the edge, and the edge might be a dynamically moving thing, and so that they can inherit sort of overarching enterprise level policy. And then ultimately, if you've got this all set up, you can redesign your policies as you move your dynamic groups of assets around, right? So I can change the properties. Let's say it's a syslog server, or it's an NTP server, or it's an ACL, or it's a routing neighbor. I can change all that via a dynamic group of routers or switches or firewalls or whatever it is you're tracking. Step 4 is use templates to do the work. And this is a very simple slide that conveys simplicity. This is where the hard work is. Templates, if you know templating languages, they are very powerful. They support semantics, so you can use all sorts of logic through them, but they're the way you represent the actual vendor-specific syntax in a variable-driven format, and we'll look at some of these as an example in a moment. This is where all the work is done. The easy part is tracking your assets. Actually, that's not that easy. The easy part is organizing a model about your operations. That's relatively easy, but the templates is tough. It's a one and done though. Once you make your templates, you can reuse them for all sorts of operations. So putting all that together, how does this work? How does intent-based networking work? First, you select your targets, and that's probably a dynamic group, as we talked about earlier. It could be something that's been in existence forever. It could be all the routers in CONUS. It could be everything at Fort Hood. It could be layer 2 devices at Fort Sam Houston. It can be very dynamic. It can be a mission set, and we'll talk about that in an example. Gather the actual configuration for those devices, so go back them up. Like, go get the running configuration. Get that information, certainly before you make a change, but also to feed the template. The third thing is you associate context with that dynamic group, and we'll look at context in a moment to make that concrete. You use that context against that dynamic group. Use the Jinja templates or any sort of templating language that you've got, and it builds configuration. It builds the running configuration that you can then validate for compliance, and then push to a limited set, like maybe a canary set, or maybe if you're confident, push to the full set of the dynamic group, and actually make your changes. If you go about doing this, rollbacks are very simple, because you just change the group content and that rolls back the configuration because you've inherited the policy from above. You're just changing what has been inherited for a more specific colloquial configuration. All right, so here's the use case. And this is actually somewhat pertinent because Jamaica's getting pounded right now, or got pounded yesterday. And so there's probably going to be a humanitarian response. Probably Southcom, could be GUARD, could be Marines. There could be a number of different organizations going down to help with disaster relief. How do they communicate? Is there a way that we can use existing infrastructure to reconfigure it, to allow it to do its existing mission, but to overlay a new configuration that allows it, like a closed VRF, allows communication with this group of people to do a thing. So in this particular situation, the enterprise and the theater context remain in force. Nothing changes like at the high level. You're still enforcing STIG, you're still got all your policies in place, but you're adding a mission context to do layer 2 and layer 3 changes. You got to change ACLs, you've got to do a bunch of different things. Maybe you have to add different sort of AAA plays. But that would be part of the mission context, which has a heavier weight. So that inheritance model is broken for those particular parameters that can then be effectively rendered against the template and pushed out to the devices. And then when the mission's complete, you take that dynamic grouping away and all the configurations go back to as they were. So it's a very clean way to make changes very rapidly, as long as you've got the templates in place and you've got the configuration context in place and the devices in management. So here's an example of configuration context. In this particular situation, we are defining an ACL. It's as simple as that. I mean, it's pretty gobbledygooky here in terms of the structured language, but you can see at the bottom that we're effectively adding a source and a destination to an ACL. In a real world situation, this could be hundreds of lines long, and it might be defining way more than ACLs. It could be defining routing parameters, could be defining any number of things. In this situation, you can see there's like basically a where clause at the top, and that is defining the dynamic group. And that's saying that anything that is tagged with HADR high is active as an asset and is a provider router. So in this case, we're changing the ACLs for the routers that fit that description in our environment through this configuration context. Here's the Jinja template that actually renders that in the iOS syntax. Okay, so we might have to have multiple Jinja templates because we might have multiple vendors providing routing functionality. Regardless, they're all using the same information behind their ACL, right? Like an ACL is created by a vendor using different syntax, but the bits that are in that syntax, the variables, are what matter. And so what we're doing here with iOS is just replacing these variables with the things that are in that configuration context for the things that match the where clause in the dynamic group. It's a way for us to very predictably change an environment in a multi-vendor environment. So those templates and the configuration context can be complicated. There's ways with artificial intelligence to build some of that for you. If you've got 100 assets out there, there's ways with artificial intelligence to say, hey, make me a Jinja template that represents these services on these devices, a way to get ahead of that curve. It's not perfect right now, but there are those assists with artificial intelligence. There's ways for us with artificial intelligence to vectorize the colloquial or the ephemeral facts of your operation, right? So you have a standard operating procedure, you've got a security policy document, you might have a whole bunch of documents, basically, that you can upload into the purview of an artificial intelligence agent to help you give good responses back to your templates. You can also do a bunch of things like federating data from other subsystems through MCPs or APIs to give you dynamic responses like, hey, if there's a performance problem, we want to change the infrastructure to deal with that. So what does this mean for your mission, all this effort? It means clarity, it means confidence, and it means speed. And those are things that can't be done until you're fully automated with intent-based networking using a templated approach like this. It allows you to deploy configurations extremely rapidly if you're prepared, and to roll them back when you're done with the mission, or to roll them back as needed. Some of the things we're working on right now are DIL, so anything that's disconnected, limited connectivity can be branched off from an intent-based system, so we can provide some amount of delegated administration for the folks on the ground to do work. But how do you reconcile those changes when that system is attached back to the intent-based system? things we're working on. Schema validation we talked about, that's a no-brainer. Unit tests to make sure that the configuration changes that we want to put in place are real and are effective. AI, always need to be doing retrieval grounding. That's basically just saying, do the things we're doing with AI support our SOP? Does it support our policy? Does it support our facts about our operation? And then blast control, things like limited deployment just to make sure things are good. These are all typical ways to solve and mitigate some risk. So what do you do? Where do you start? You can start today just by picking, could be in the lab, could be in a small environment, but go through the steps. Go through the steps to represent your organization. Go through the steps to track all of your assets. Start working on templates in a small form just to control drift. You don't have to go and change swaths of global infrastructure. You can just make sure that your gear is configured as intended. That's just the easy way to start, and it doesn't even infer that you're automating change. It's a way to get your toes wet. It's a way to learn the systems and to learn the templating languages so that you can go on to greater things. Start small and then grow with confidence. Before I finish, I just wanted to mention we're downstairs. Come talk to us. We're doing a bit of a contest where you have to describe to us your worst challenge, or the best IT challenge, or the worst, what is it, the hardest IT suck, which is interesting. We'll donate to a charity of your choice, $20, if you come fill that out and give us some challenges to solve with our software. At the end of the day, we'll pick a winner, and then for that winner, we'll donate $500 extra to that charity of choice. So trying to give back to the community, but also, hear from our customers and our to-be customers about how we can help you. And that's it. If you want to learn more, you can use these QR codes. Come visit us down next to the, I'm going to pronounce this improperly, but I'm going to try the Kuka Theater. I think that's right, downstairs. So happy to see you, happy to answer any questions today or tomorrow. We'll be around. And I think that's it. Yeah, I'm going the wrong way. All right. I'm a little bit over time. Anybody got any questions? I'll happily answer it in the hallway, or I'll happily answer it downstairs on the floor. But I thank you for your time and attention. Again, my name's Tate. Come talk to me. I'll show you the software that does all this stuff.